Okay, we're going to wrap up chapter 8 today talking about polyatomic ions. A polyatomic ion is an ion composed of two or more atoms that are covalently bonded together. And so remember when we learned about ionic compounds, we would have a metal and a non-metal that were bound together by this ionic bond. The metal would basically give up valence electrons that the non-metal needed so that it would be ideal, and as a result of that, the metal would carry a positive charge and the non-metal ion would carry a negative charge, and it would be that opposing charge that held the ionic compound together. Well, we want polyatomic ions. That's an ion. It carries a charge, but it's composed of more than just a single element like we had in our previous ions. This ion is composed of two or more, and those atoms are covalently bound together. Let me show you one common one. Take, for example, hydrogen, which has a single valence electron, and oxygen, which has 6 valence electrons. And if those were to combine together and share electrons, it would look like this. Well, what's the problem here? Hydrogen's ideal in that it's got 2 electrons, but oxygen's still lacking 1, right? And so as it turns out, this is, since it's still 1 electron short of ideal, then this electron, then it needs 1 more. Well, if we've got a metal floating around somewhere nearby, for example, sodium, that has a single electron that it's willing to donate, we could then have it donate its electron to there. And so the result would be Na+, right, a sodium ion with a positive 1 charge, and then what we call a hydroxide ion. Since it received an electron from the sodium, it now carries a 1 negative charge, okay? So that's the hydroxide ion. O and H are covalently bound together, but they've also received a valence electron that was donated by the sodium atom here, and so it becomes the hydroxide ion. And so the hydroxide ion is one of our common ions, hydroxide ion, and it is basically OH with a negative charge. All right. This full compound, if we were to write it out, would be NaOH, and we would call that sodium hydroxide. Same naming convention that we use with ionic compounds, in the sense that the metal in the front here, we just use its name just like it is in the periodic table. We just call that sodium, right? But this polyatomic ion has a special name. This sodium, it's called hydroxide, so this would be sodium hydroxide molecule. There's a list of common polyatomic ions, and you can see that on page 245. And I want you to actually memorize some of these. You only have to memorize the ones that are in bold, okay? But make sure memorize bold polyatomic ions in table on page, what is that, 245. So basically ammonia, hydronium, carbonate, hydroxide, nitrate, sulfate, and phosphate, all right? So only 7 that you need to memorize, but when I say memorize them, what do I mean? Well, I want you to memorize ammonium, and then know that its chemical formula is NH4+, right? So you need to know, basically, if I were to give you a table and say, fill in the blank of any missing items here, maybe I were to give you this, and I've left off the charge there, you should be able to write in the table ammonium, and then it's got a +1 charge, okay? And you should know the, if I only give you ammonium, you should be able to write down, if I were to just give you this, you should be able to write down NH4+, okay? So make sure that you know both the charges, what compounds and what elements and how much of each element is contained within that polyatomic ion, and then what the name of that polyatomic ion is, okay? So that's what I expect. Just a really big hint here, make sure you know those 7 for the next quiz, okay? Like I said, when we're naming these, it's a similar naming convention to what we did before with our ionic compounds. You just, whatever the metal is at the beginning of the compound, you just list its name as it is. For example, if we had this, FeOH2, we would say that that is iron hydroxide, right? So you just give the name of the metal at the beginning, and then whatever the name is of the polyatomic ion as it shows up in the chart here, okay? I also wanted to point out that the way that we would write this is we would write the OH in parentheses, but then with the 2 out beside it. And so you may be thinking, well, why not just do this? Wouldn't that be accurate as well? That's an accurate count of the atoms that are in the molecule, but the reason that we write it this way, the reason this way is correct, is because we identify the hydroxide polyatomic ion, okay? So you want to always, if you're going to have multiple polyatomic ions in there, you want to wrap the polyatomic ion in parentheses so that you identify it in the compound, okay? So we'll do an example so that we can see how you would write the chemical formula for these. And that's on page 245, example 8.8. And so it says sodium carbonate is used in the manufacture of most kinds of glass. So sodium carbonate is used to make glass. What is its chemical formula? All right. So we're going to do what we similarly did whenever we were constructing ionic compounds. And if you remember, we would do swap and drop to figure out how many of each of the atoms were in the ionic compound. So we're going to have Na here, and we're going to go to the periodic table, and we're going to look up Na, and we're going to see that Na is in column 1A. And so that means that as an ion, Na is going to carry a +1 charge, or a 1+ charge. Hydroxide, I'm sorry, not hydroxide, it's carbonate that we're looking at. Carbonate, going to our table on page 245, this is one of the ones that you're going to memorize. And carbonate is CO3 with a 2 negative charge. And so we swap and drop, and that means we bring the 2 down to the bottom of the Na, and this 1 would go over here to the CO3, so it's understood, we don't have to write it. So this would be our chemical formula for sodium carbonate, okay? Pretty simple, pretty straightforward. Let's do another one. What about magnesium nitrate? That's the next compound that they want us to give the chemical formula for. So magnesium all right, so again, we look at our periodic table. We look for magnesium, and we see that magnesium is in column 2A. So magnesium is going to carry a 2+ charge. And we look at nitrate in our table, and nitrate is NO3 with a 1 negative charge. So when we swap and drop, the Mg is going to have a understood 1 down here. NO3, though, is going to have this 2. And so we're going to have to put NO3 in parentheses and put the 2 there so that we still can identify the nitrate polyatomic ion in this compound. Okay? So I think that's pretty simple, but of course, as always, let me know if you have any questions about that. A couple of final comments on polyatomic ions. Though ionic compounds are that are formed by polyatomic ions, they're very similar to the ionic compounds we've already studied. There are a couple of important differences, namely for compounds, let me write it this way. For compounds with polyatomic ions, they contain physical bonds, not just bonds based on the attraction of opposite charges. So in other words, this compound contains covalent bonds as well as ionic bonds, right? And then also, I proved 3, not 2. They are not always formed by metals and nonmetals. So all of our ionic compound examples, we had a metal combined together with a nonmetal. That will not always be the case with polyatomic ions. Take, for example, this compound, NH4, NO3. Right? If you look again at our table on page 245, you'll see that both of those are contained within that table. NH4 is the ammonium ion, and then NO3 is the nitrate ion, right? And so this is ammonium nitrate. Compound comprised of 2 polyatomic ions, okay? So remember, for next time, make sure that you memorize all of the 7 bolded polyatomic ions on page 245. Why is it important that we know these? Well, these are really common, right? Some of these are found in several of our common household items. So again, just taking a glance at the chart there. So just to list a few of those, baking soda contains HCO3, right? Very common household item. Bleach contains ClO, negative. Many of our detergents, ClO3, negative, another polyatomic ion. Dairy products, PO4, 3 negative. Nail polish, C2H3O2, that's acetate. Chalk contains CO3, 2 negative. Is that one of our special ones? Yeah, that's carbonate. And then fertilizer often contains the ionic compound that we just mentioned a moment ago, which is comprised of 2 polyatomic ions, ammonium nitrate. So that's why we need to know about these, right? They're very common. We've got them all in the products in our household. So that's the end of chapter number 8. Hey, got another shirt, very similar to the last one. I wear this shirt periodically only when I'm in my element. So another cool shirt. Thank you that I have such great students that keep me well supplied with cool chemistry t-shirts. So you guys have a good day. Let me know if you have any questions, and Lord willing, I'll see you next week.